Hi, my name is Sophia Zane from Mr. Farrar's Period 3 class, and today I'll be talking about the Net Change Theorem. So, the Net Change Theorem is derived from the first fundamental theorem of calculus, and it states that the definite integral of derivative big F from a to b is equal to big F of b minus big F of a. This represents a rate of change. Pardon my sloppy handwriting. So basically, the net change theorem represents an accumulation of something over a period of time. So a notable example would be, say, if you're driving a car and this represents the velocity of the car, then you can use the net change theorem to calculate how far you've traveled in a period of time. Alright, let's move on to our first example question. The density of cars, number of cars per mile, on the highway going to CCA is equal to 200 times the quantity of 4 minus ln 2x plus 3, where x is the distance in miles from the school entrance. Find the total number of cars on the highway 10 miles away from the school entrance. So in this scenario, we can use the net change theorem as they're asking for an accumulation of cars on a period of 10 miles, if you want to think about it that way. So then we can write this as a definite integral of a lower bound of 0, upper bound of 10, and 200 ln 2x plus 3 dx. And then since 200 is a constant, we can just move it out in the front. So then it would be equal to this. And then we look into this thing, and now we need to take the antiderivative of this part right here. But then we don't know how to take the antiderivative of ln yet, so we'll have to use our calculator. And as I wrote up here, it is calculator OK. So we just punch this directly into our calculator, and we get an answer of roughly 3,118 cars. So yeah, this is a pretty simple question since I allowed I allowed a calculator usage, but if there was no calculator, this would be pretty difficult. Regarding calculators, it's pretty useful if you can take integrals with it. On my TI-84, by pressing math and scrolling down to INTA, I can calculate definite integrals. However, to calculate indefinite integrals, I actually need to go online and manually download a program. For other types of calculators, there are plenty of resources online that you can use to understand how to use your calculator and how to download programs. Another thing to note of while doing these kinds of questions is that the net change theorem is extremely antiderivative heavy, meaning that you need to be able to take antiderivatives. You have to take antiderivatives quite often, and if they don't give you a calculator, that could be difficult if they give you some extremely nasty thing for you to do. So I would recommend that you should practice doing some antiderivative stuff before you actually start doing the net change theorem, because that will help you in the long run. Okay, let's move on to the next and final question I have for you. So, there's a rumor going around that Mr. Farrar steals the hides of freshmen from Mr. Shea. On the 6th day, Mr. Farrar is exposed and publicly shamed. If the rumor is spreading at the rate of 100e to the negative 0.2 t new people every day, how many people have heard the rumor on the day Mr. Farrar is exposed? Okay, so once again in this case, we can use the net change theorem, and we can rewrite this as like this. And then since 100 is a constant, and we can just move that out to the front. So now it becomes this. And then at this point, we could just take out our calculators, plug it in, and we'd theoretically be done. But say this question was on like a no calculator section on your test, then you wouldn't be able to do that. So I will just demonstrate how you continue the process of doing this question without a calculator. So then you would have to take the antiderivative of this part. So then that would be 100 times 1 over negative 0.2 e to the negative 0.2 t 60. And then we just plug in 6 and 0. So 100, 1 over negative 0.2, e negative 0.2, 2 times 6. Minusing a negative is just plus. So, yeah, plus. And then e to the 0 power is just 1, so 1 over 0.2. And then we can simplify a little bit, and then this is negative 5 e to the negative 1.2 plus 5. And then we distribute the 100, so negative 500 e to the negative 1.2 plus 500. And if this is no calculator, we'd be done here, and this would be our final answer. But then, since this isn't a test, and I don't really know what kind of number this thing here is, so I'm just going to punch it in a calculator, and we get that this is roughly 349 people. Okay, I know I said that this is going to be our last question, but there's another one that I want to go over because I feel like it's important. So, time for the next and actual final question. A particle moves along the x-axis so that its velocity at time t is given by vt, which is 6t squared minus 18t plus 12. And it wants to find the displacement of the particle and the total distance of the particle travels from t equals 0 to t equals 4. So, displacement, or part A of this question, is asking for displacement. So then, displacement of the particle from t equals 0 to t equals 4 would then be represented by the particle's position change from this time. So, by the fundamental theorem of calculus, it would just be, oh, that's general form. It would just be this. And then we solve this by taking the antiderivative, so 2t cubed minus 9t squared plus 12t for 0. And then we can just ignore the 0 because anything times 0 is 0. And subtracting 0 does nothing. So then we just plug in 4. And we get 32 as our answer. And then the net change of position from t equals 4 to t equals 0, this is sometimes referred to as position shift. And here it indicates that the particle ended up 32 units to the right of its starting point. And then this would be 32. Yeah. And then part B is asking us for distance. And so Vt is equal to 6t squared minus 18t plus 12. If we factor this out, we get that it's equal to 6 times t minus 1 times t minus 2. And if we make a little chart, we get that if t is less than 1, v is positive. If t is between 1 and 2, v is negative. And if t is greater than 2, v is also positive. And this is a little troublesome as the particle is not always going forward. So if we just left it as just in this form, we would get displacement, not actual distance traveled. So we want to force all the parts where it's going backwards to be positive so we can count it in as distance. So then we would put absolute value bars around Vt to force it to become positive. And then when removing the absolute value bars, we have to keep in mind of the sign. So in this case, 0 to 1 of Vt, that's already positive, so we can just leave it be. However, from 1 to 2, it's negative. So that means we have to put a negative sign in front to make it become positive. And then once again, when it's greater than 2, it's positive, so we just leave it be. And so yeah, that's basically how you break it into small chunks. So this right here would actually represent the distance it traveled. And then once again, we take the antiderivative of everything, and then we plug in all these values to solve it, and we should get 34. So yeah, that concludes this video. I hope you enjoyed. Thanks for watching, and I hope this helped.